Capital Budgeting Screencast 2, picking up right where we left off. So we just talked about net present value. Now let's move on to talk about the internal rate of return, or the IRR. So the internal rate of return is also a capital budgeting measure. The definition is right there for you on the screen. It's the discount rate that forces the present value of a project's inflows to equal its costs. It's literally the discount rate that forces a project's NPV to equal 0. There's the equation for you. It can be kind of a pain to calculate, so we'll just use our calculators. One thing to note for you is that the internal rate of return as a measure is the preferred technique in the industry. This is the technique the financial managers like the best, okay? And it's a rate of return, so it's a percentage. So let's look at these same two projects we just looked at for net present value, and we're just going to use these same projects to compute all of the techniques. Notice that I've got the problems right into this PowerPoint that I built that I'm using for the screencast, basically. Let's do the IRR. Let's put that to use. Okay, so now we've got our financial calculators in the picture. Let's go ahead and do project A. So cash flow worksheet, that's where we need to start. Push second, clear work. So your cash flow worksheet, you need to have your costs, plug it all in, the exact same thing you just plugged in for net present value. Plug in these cash flows. I'm plugging them in rather quickly here. I think you can follow what I'm doing. I think you've seen me do this a couple of times, so I'm hoping you're getting the hang of it. So cash flows for project 1, boom, there they are. Okay, so now what do we do? If you look at your calculator, notice right next to the cash flow worksheet, you have the net present value. You've been using that. Now we're going to use the new button you haven't used yet, the IRR. So push that button and push compute, and bingo. There's your IRR. There's your internal rate of return for project A. It's at roughly 18%. Go ahead and do project B. And notice we didn't go back to net present value. We didn't plug anything in to the interest rate. And I'll talk about that in a second. So project B, plugging in those cash flows. Second year, 3,000. The last year, 6,000. So IRR, compute, ta-da, there you go. So the IRR for project B is 15.56%. You can round to the second decimal place, that'd be fine. It's a percentage. I can't stress that enough. I haven't been too picky, and I'm not usually in the online class, but my biggest pet peeve is mislabeling of answers. So just a side note, IRR is a percentage. So what do we do here? Which project does the firm accept, etc., etc.? Well, the rationale with the IRR method is similar to net present value. And I'm going to get rid of my calculator here for a second. So here's how you make your decisions. The rationale for the IRR method. If the internal rate of return, if the IRR is greater than the cost of capital, then the project's returns exceed the costs. Essentially, it's telling you there's a return. It's offering some value to the firm in a rate of return instead of in dollars like net present value. So if the IRR is greater than the cost of capital, we accept the project. If it's not, we reject the project. So the weighted average cost of capital was 10%. We don't need it to compute IRR, but we do need it to make the decision, okay? So in this case, for both projects, the returns were greater than the cost of capital, so you could accept them if they're mutually exclusive. Take the one with the higher internal rate of return. If cost of capital changes, if it goes up to 12%, then what? Well, your answer won't change, and you can fool around with this in your calculator. Your IRR will stay the same. The decision might change given the different rate of return that you're looking at, the different costs of capital, okay? So comparing these two methods, If projects are independent, meaning you can accept more than one, then these two methods, net present value and IRR, which by the way are the most common methods, then they will lead to the same decision. Okay, they'll lead to the same accept or reject decisions. If they're mutually exclusive, meaning only one of the projects can be pursued, then they will lead sometimes, not always, to different conclusions. So what do you do then? Then you use net present value because it's the single best measure. It will always lead to the best decision regarding value added to the firm. So if you're looking at mutually exclusive projects, net present value is the method to use. Okay, so those two methods, most common. A couple of other thoughts before we go on to our third technique. Reinvestment rate assumptions. What are we talking about when we say reinvestment? Well, cash flows that have been coming in from the projects, they're reinvested ideally. That's kind of how it works in finance. The assumption for how those values are measured for net present value and IRR is different. Net present value as a measure assumes that cash flows are going to be reinvested for the firm at the firm's cost of capital. That's a good assumption. That's the firm's required rate of return. It makes sense. The IRR method assumes that cash flows are being reinvested at the IRR instead of the cost of capital, which is the flaw. Okay? That's the big flaw with the IRR, that reinvestment rate assumption. I cannot stress this enough. The takeaway from the previous slide, both methods lead to the same decision for independent projects. It's when they're mutually exclusive projects that a firm is looking at, or that we're looking at here in the classroom environment, that we need to consider that they may lead to different decisions. And I think there's some problems in your textbook where you may get to fool around a little bit with that, with the two techniques leading to different decisions. So it's when you're looking at mutually exclusive projects that it's important to use the right method, and that is that net present value method. So the question that maybe you're raising in your mind, it typically comes up in the face-to-face environment. If net present value is better, why do managers like to use the IRR? Remember, I told you that that was preferred by financial managers. Why do they like that better? They like it better because it's a rate of return. Financial managers are constantly looking at things in that respect. So it helps them for comparative purposes. And that's pretty much the gist of it. All right, so since managers like a rate of return, is there another measure that will work? Is there a better measure than the IRR? Yes, there's something called the modified internal rate of return, or the MIRR. The modified internal rate of return is a discount rate that causes the present value of a project's terminal value to equal the present value of cost. This thing called the terminal value, it can be found by compounding the cash inflows at the cost of capital. The MIRR overcomes one of the flaws with the IRR, and that's its reinvestment rate assumption. Okay, so it overcomes that, gives us a better reinvestment rate assumption. So how do we do this? Here's the same projects we've been looking at all along. I sketched it out for you on a piece of paper, and I'm going to go to that document and you can see how we do this. Your textbook author also goes over it too, but I sketched it out in handwriting and I'll kind of talk you through how to do that. So here's our cash flows, same cash flows we've been looking at all along. We're going to find the MIRR for each. Okay, so this modified internal rate of return is the discount rate at which the present value of a project's cost is going to be equal to the present value of its terminal values. That's what That's what we're doing. So in finding the MIRR, the first step is to find the terminal value. And the terminal value is the compounded value of cash inflows. Okay, kind of a keynote there, inflows. So what do we do? How do we do that? let's look at the cash inflows. I set it up on a timeline. Sometimes it's useful and helpful to do that when looking at MIRR. So we've got the 3 cash inflows. We've got the cost. We'll leave that over there. We're not going to do anything with it right now. So let's find the terminal value. The terminal value is the sum of the future values of those cash flows compounded at the cost of capital. So $1,000 in year 3 at the end of year 3 is going to be $1,000. There's nothing to do with that. That's good. So $3,000 in year 2, we need to find the future value of that $3,000 over 1 year compounded at 10%. And when you plug that into your calculator, you should get $3,300. Then cash flow 1, $5,000. We need to find the future value over 2 years compounded at 10%. And when you do that, you should find $6,050. Add those 3 amounts together. That's your terminal value, $10,350. The terminal value is the sum of the future values of the cash inflows compounded at the cost of capital, and that's what we just did. That's what this is. So step 2 is use that terminal value to find the MIRR. So this terminal value becomes your future value, $10,350. Now we can bring in our cost, that negative $7,000, that's your present value. Over 3 years, that's how many cash flows we have. And then you can compute for the I in your calculator. And that's your modified internal rate of return. That's the discount rate at which the present value of the project's cost is equal to the present value of its terminal value. Okay, that's what it is by definition. So project 3, do the exact same thing we just did above, but with the different cash flows. So you find the future value of these 3 different cash flows. $6,000 at year 3 is $6,000. $3,000 for year 2 over 1 year. Okay, we only have 1 year in between year 2 and 3. At 10% compounded, and you should find a future value of $3,300. Once again, that was incidentally the same cash flow 2 as in project A. And then cash flow 1 was $1,000 compounded over 2 years at a rate of 10%. You should find that that's $1,210. Add the 3 up and you should get $10,510. That becomes a future value. Your cost is your present value over 3 years. Compute I and you should get 14.51%. So what's the rationale? How do we know what to do here? You accept the MIRR, or excuse me, the project with a higher MIRR, and in this case it's project B. And the MIRR does need to exceed the cost of capital as part of the rationale. So why would a firm or why would financial managers use this MIRR instead of the IRR? Well, it assumes reinvestment at this opportunity cost, at the cost of capital. It's also the firm's required rate of return. Also avoids the multiple IRR problem, which I haven't even mentioned, but I'm going to tell you, read about that in your textbook. Managers like a rate of return for comparisons, and MIRR gives them what they like, essentially. They can use that rate of return for comparison purposes that they like so much. So our fourth and final capital budgeting technique, the payback period, what is it? The payback period tells us the number of years required to recover a project's cost. It literally tells the financial managers how long it takes to get their money back. In a sense, it's a break-even analysis, basically. It tells you at what point over time do you break even. We can calculate it by adding a project's cash flows or the cash flows of multiple projects to the cost until the cumulative cash flow for the project turns positive. So same 2 projects. The question is, what is the payback period for each project? And I sketched that out for you since I don't have a whiteboard, which is what I'd use in the classroom. I have that sketched out for you, and let's go to that and put this thing to work. So your textbook authors also go over the payback period, and here's the equation. I think think they state it in some light similar to this that I typically give my students. When we compute the payback period, what we're doing is we're finding the number of years prior to full recovery by adding the cash flows to the cost until the thing turns positive, basically. So we find the number of years prior to full recovery plus the absolute value of the unrecovered cost at the start of the full recovery year divided by the cash flow during the full recovery year. Okay, so you can jot that down if you need to. What do we do there? How does that make any sense? Let's look at Project A. So we have a cost of $7,000 at year 0. If we add $5,000 to that $7,000 in year 1, our running total is basically $2,000. Okay? You can see, given that there's $2,000 in unrecovered costs at the end of year 1, that by the end of year 2, Project A will have recovered its costs. So the number of years prior to full recovery, in this case is 1, we already kind of saw that pretty quickly, plus the absolute value of the unrecovered cost at the start of the full recovery year, it was negative $2,000. That's why we say absolute value, because a negative number isn't going to do anything for us, essentially, divided by the cash flow during the full recovery year, and that's $3,000. Put that together, and 1.67 is your answer, and the payback period is measured in years. Okay, so that's our answer, or excuse me, that's our payback for Project A. And let's do the exact same thing for Project B. Project B, same cost, $7,000. Cash flow in year 1 was $1,000. Add that to the cost, and at the end of year 1, the unrecovered cost is negative $6,000. Okay, great. Add the cash inflow for year 2, $3,000. The unrecovered cost then is negative $3,000, and you can see between years 2 and 3, it's going to go positive. So 2 years, that's the number of years prior to full recovery, plus the $3,000 cash flow, excuse me, that's the unrecovered cost, the start of the full recovery year, divided by the cash flow in the full recovery year of $6,000, and you get 2.5 years. That's the payback period for Project B. Okay, 2.5 years. So how does a firm make a decision using that payback period, and should they? Well, it's not the best method. There's some weaknesses. It ignores time value of money. That's not even brought into the thought process with a payback period. And we don't do anything with the cash flows that occur after the costs have been recovered, essentially. So it's not the best measure. If it was being used for decision-making purposes, the firm would want to choose the project with the quickest payback. The strengths, is it even used? Is there a valid use for it? Sure. It's a quick and easy measure. Oftentimes, financial managers or anyone that's good at calculating numbers in their head can quickly do a payback analysis, oftentimes just in their head. So there's a definite strength there. It's easy to calculate, easy to compute, easy to understand, provides a very quick indication of a project's risk and liquidity. So there is a strength to it, but it does have those weaknesses. So that's capital budgeting in a nutshell. I don't include another problem set because I just illustrate, I think it's pretty straightforward how to solve a capital budgeting problem. So I just do one set typically, as I just did, right within my lecture here for you. So I highly recommend you do some practice problems in your textbook. It will help you understand and comprehend the capital budgeting techniques even more. Read about some concepts. I did not even talk about a couple of these things, so I make a note to you. Read about normal versus non-normal cash flows. Read about net present value profiles. Read about multiple IRRs, and read about the conclusions on capital budgeting techniques. Any questions, by all means, let me know.